Basically, the next panel is a discussion about, well, it's called Back to the Future. So you understand that it's about new technologies, about new workflows, and how the workforce is augmented in a way using the new technologies.
We will be discussing augmented manufacturing environments. In my very simple definition, this is about using digital technology to augment the capabilities of machines and of humans in the manufacturing environment, but while still fostering the synergy between machine and the human. But this is my definition, so I would like to start the panel with each one of you. Maybe we start with Dimitris, with Professor Kiritsis, but it's a common intro for all of you. So introduce yourself and your organization, and so you introduce yourself, not me, and you give your definition of augmented manufacturing today with a simple example that our audience can understand and can relate, if possible.
You hear me? Okay. So Dimitris Kiritsis, Senior Advisor at the University of Oslo, Professor Emeritus from École Polytechnique Fédérale de Lausanne. Some of you know me, I think. So augmented manufacturing, so my definition is that it is solutions and tools that allow elements of manufacturing to do things that are beyond their usual capabilities. So usually we, let's say, make reference to humans and human augmentation. And there you may have examples, physical augmentation with exoskeleton, for examples, or cognitive augmentation with XR or virtual extended reality or virtual reality material. And the application in the exoskeleton is manual assembly, for example. In the cognitive application is to, for example, machine monitoring or visualization of elements of machines, etc. But beyond humans, you have also machines that can be augmented that may become, let's say, mainly the cognitive augmentation. For example, with edge solutions that allow machines to understand their environment for predictive maintenance, for example. And just note that particularly for this domain of application, machine augmentation, things may become commodities. Take the example of machine tools. So machine tools were manual machine tools. Then you have numerical control. Then you have computer numerical control. And this computer numerical control is a commodity today. But if you go to predictive maintenance, to real monitoring is something that becomes more exotic, let's say.
And augmented. So, Nikos, the same question. Introduce yourself, your company, and maybe with an example.
I think I can skip the introduction.
Because you haven't been already introduced.
You have heard a lot about me. Don't get rid of me.
You always get one chance to make a good first impression, right? So
yes, I think I did one impression. So yes, to me, augmentation, I like to play with the words. Augment means to give, let's say, in a free translation, to give something more to what it's already there. So in terms of humans, I think how we can augment a human being. What makes human human? Thinking, but how do we think? We think based on what we perceive, right? So perception. We think based on what we understand, so cognition. And I have a metaphor that I like to use, is that they say old people are wise. Why? Because they have experience. So they don't, if their brain works and do remember and they are not in a dementia state, you get the feeling. So what is an AI system? It learns, it has seen many things, so it can be augmented and can predict. And humans, I think it's the same, how we can augment a human being, either by physically or cognitively. So theoretically speaking, if you can give to a human more digestible information, I think it's easy. And just to give it also in a hands-on example, To me, and the future would be, I am going to a factory shop floor without any training at all, and then I have to use any machine. The system will know, the system is a full factory, will know who I am, what is my background, and it will adapt to me. It will speak Greek, because I don't speak any English. It will give me information in my eyes in order to help me operate, and when I struggle, it will understand that I struggle, so it will give me more and more information to help me going. So you won't need that much training. And this is, I think, a combination of augmented machines that are self-aware somehow and adaptable, and humans that are augmented through their environment.
Sure. Question is the same for you.
Maybe this one as well. Or maybe I use that one. Maybe, okay, sorry. Good afternoon to you all. I'm Pedro Malo. I'm from Portugal. I'm both a professor at university, at Nova University, and also have a company which we work on acoustics, for instance, and software, of course. But acoustics could be one of the elements, talking a bit on the augmentation, that could augment the people, right? So I could go in a different direction also, for the people that have some difficulties, some impaired, that cannot listen so well or cannot see so well, right? To complement a bit on what the colleagues have said. So augmentation could be also people which have some difficulties, some less capabilities in some of the senses may be augmented to bring back a bit to what the normal human being could be able to perceive and to sense, and even, of course, go even further, right? It could listen to the environment, if we talk about acoustics, or in terms of vision, to augment the vision. If you think a bit, looking a bit on the context that I see now, I've seen that factories in China, for instance, there are starting to be a lot automated, majorly automated, and it's places where you see which is lights out, so there is no light there, only very small focus of light where the robots and the machines are really needed some lighting, which means that a person needs to be augmented for sure, because he cannot see in there, right? There is also already a need for some goggles for the people to go inside and to perceive. Another thing is that there is no air conditioning. It's completely cold place. So also people need to be feeling comfortable in there. So this is one of the things that I see, and I think that we will go more and more towards automation and automated factories, lights out manufacturing, and so this domain. So the human needs to be clearly augmented in order to cope with these things. Of course, if we think that this is going to also happen, it means that remote maintenance, remote operations is needed. So of course, augmentation needs to be clearly there in order for you to perceive what is happening in the factory. And if you even see it further, imagine that you go into the moon and you have manufacturing in these remote places. So you really need augmentation for people to perceive what is happening there. So, okay, this is a bit of the augmentation that we can see. Of course, there is also the augmentation of the machines, but I think Sergio can talk a bit on that.
Let's give it to Sergio. Of course, you mentioned a lot of examples, so Sergio has to be creative, but I'm sure he will be. I will buy the big memory from the 3 examples. I'm going to buy, if you give me something that gives me an infinite memory, this is the one I buy after 50 years old. But Sergio, can you be creative? Give more examples. First of all, introduce yourself.
Sergio Gusmeroli, Politecnico Milano, and made Competence Center. And so Politecnico di Milano for scientific research, lower TRL activities. Made the Competence Center is a TEF, so a testing experimentation facility for AI in manufacturing, and it is the major leader of the EDI, European Digital Innovation Hub in Lombardy. And Lombardy is the region of Milano, is 10 million inhabitants, and many 100,000 companies. So I cannot agree more with the other colleagues. So my point is that the final aim of augmentation is collaboration. is human-machine collaboration and the so-called collaborative intelligence, train, explain, sustain, from hardware business review. And in order to do that, we need that both parts are augmented. And the two augmentations need to be synchronized. And the most effective way, in my opinion, to synchronize the two augmentations is to use AI. And to use AI in order to understand what the machine can do with augmentation and what the human can do with augmentation. And I also have, in my project, in the project I'm coordinating, which is called AI Reggio 5.0, we are using the WISE metaphor. WISE means well-being, inclusiveness, safety, and ergonomics. And this is the final aim of this collaboration. And I would really say that augmented workspace is our final aim, where the workspace is made of different workplaces, because the human could go from one workplace to another workplace to another workplace in a seamless way. And so this concept is based, of course, on augmented machines and augmented workers. But of course, we need more collaboration, more intelligence in order to make this process more flexible and respective of well-being, inclusiveness, safety, and ergonomics.
Okay, so I think we've seen from this introduction that augmented manufacturing is much more than technology, right? It's also organizational factors, it's also human factors, ergonomics, safety. But because I know our audience is tech savvy, I would like to start another round talking a little bit about the technology behind augmented manufacturing. So I would like to start with Dimitris. I remember, Professor, I've read some of your papers in EPFL, but now also in Oslo, and you make these very nice taxonomies, right, of technologies, also for the knowledge modeling and so on. So what's the taxonomy behind augmented manufacturing? What is it? AI, digital twins, extended reality? Break this down for us a little bit.
Yes. In the first round, we touched also elements of this. For example, we understand that we have human augmentation. We started with that, with XR, etc. We have physical augmentation and cognitive augmentation of human capacity. We have physical machines augmentation. And then we have also the human, the workspace. We have the system augmentation. So in the human augmentation, so in the machine, let's say the machines, the assets in a factory, etc., you have what makes machines have augmented capabilities, sensors and Internet of Things connectivity, for example, and then software, edge computing, cloud computing, AI, agentic AI. Today, we have all these technologies. In the human augmentation, so you have in the physical augmentations devices like exoskeleton that I mentioned, or for visual capacity, or for auditive capacity, or for even body capacity, all these devices that augment physically a human. For the cognitive augmentation, so you need to have the data, the communication, so wearables, for example, or the glasses that are coming now that allow to see beyond. You can see your eyes. And then you have the cognitive, how all this is transformed and linked to our human with the chatbots, with the AI that helps send recommendations through the various user interfaces. And the system augmentation, I think it's what is becoming more and more important. And thanks, Sergio, for mentioning that. So here you have, first of all, the workspace is a system, it's a complex system. So first technology is system thinking. Understand the system by system modeling, for example. Model-based system engineering is a technology that is very important. It has become very important. Digital twins that we have seen are elements that help to see the augmented systems, how they work. the multi-agent system. Agentic AI is in fact a multi-agent system, which is a very old concept. And then don't forget that we mentioned also before in one of the first speeches, the data. Data are very important. So 20% only are used. Why the others are not used? Because maybe they are not good quality or not in good form or not understood. So now you have all these elements, all technologies, AI, agentic, LLMs, they are converging, having as source of input semantic models for the data. And I would say since system thinking is important, we may go from system models all through transformations to knowledge graphs, which is the state-of-the-art tool to collect knowledge. So these are basic technologies that can be used to have augmented systems from all the elements of manufacturing. So the machines, the humans, and the system.
Okay, so now we got the overview. Nikos, the question is the same, but I would like you to filter out these technologies and maybe prioritize some of them from your perspective, because we heard almost everything, right, in terms of tech. So if I want to achieve the simplest augmentation use case on my factory, what do I have to deploy?
That's
a
tough one to filter,
give
but
your direction, right? I don't want to intervene.
I'm a visual person, so I will try to visualize also for you. So what's the problem that we need to augment? What do we need? Data. Are the data available? So in a yes or no, do we have enough mechanisms or the right mechanisms to exploit 100% of the data in the form, etc. So we need data collection techniques, if not there, so sensory system. Smart sensors, I have to say that they need to be ready with protocols. Then we need something about IoT to collect data and use some cloud to make them available for multiple locations. And then traditional, old school technologies like cameras, but tweaked to be smart, and not only smart, to be cognitive and have, agents and AI to help. Just to clear it out, agents are not a magic wand. You still need traditional AI and traditional systems to operate. Without them, you are doomed. So if I could say so, what I would add to this list is the connectivity. Because I like the idea of having factories in the moon. It's the level of crazy that I like. But apart from that, it would be possible if you have a really strong connection, stable connection. You don't want to miss data. That's the important stuff. And it was mentioned before that you can do operations from Australia to wherever you are with Da Vinci robots, etc. So I think it's essential to have secure connections and high-speed connections to allow them to transfer all this data. And just to finalize this train of thought of mine, I've seen the last keynote of NVIDIA. And Jensen's presented this huge pile, I don't remember the official name. And he said, do you see this column? And they nodded, yes, we do. Only this part can transfer the entire internet of today of data. And it had, I don't know how many. So in hardware, we have achieved it. But I don't know if we can do it remotely just to increase the scale. Because otherwise, you have to invest in hardware in every single location. But maybe, just maybe, if you have good connection, good infrastructure to run the models elsewhere, we can return in a paradigm like before. The computer will be the room, yes, and you just have a terminal. So I think you also mentioned it sometimes that you don't need a mobile phone anymore. You just need a chat and gives you any information you need. So I think this is where we should go. Okay, excellent. Now, because I see also the clock ticking, and I wanna cover also other stuff. I would like to change the question to Pedro. I wanna take from the mood to the reality of Greece and Portugal. Most companies are
small, medium enterprises, right? They are small, medium. We have some large enterprises in Greece, but they are not the majority. Maybe it's the same in Portugal. So the question here is all these things that we are getting at. So good data, 5G, connectivity, maybe knowledge models, expensive consulting. Is this just a game for large manufacturers, for large factories, or the smaller and the small medium manufacturers can also benefit, and how?
Okay, thanks for that question, John. Nice question. I think it's the fabric of Europe is mainly SMEs, right? So, of course, there needs to be, and it is for sure, there is a play for the small and medium enterprise and for this new wave of technology to enter also in the factories. I've seen from the past, I remember from the PLC, which was a very closed thing, then it started opening with open PLC and also starting to be hardware agnostic and all that. So there is a possibility of the SMEs to enter in this business. How, for instance? Many SMEs are coming from spin-off companies, right, that start from universities. And normally this research is very good research. I think we do very good research in Europe, right? What we fail is to do the next mile, the extra mile then for the market. And I think if we have some kind of an environment to scale up this research, then it's easier for the small enterprises to enter really in the market. I know a lot of developments that are happening in Portugal and in Greece and elsewhere, where companies are developing new sensor, for instance, new technology that is really interesting and can really play a role into the manufacturing of the future. And I see that maybe the SMEs that are existing today will also change a lot in the future, and there will be a lot of state play that can evolve. But in Portugal, I think one of the things that we could really be interesting, right, and I see it a bit limited, is we lack data, right? In Europe, we lack a lot of data to train AI, particularly. And one of the directions that maybe Europe could take, also that will help the SMEs, is to try to create environments, virtual environments, where we could generate loads and loads of synthetic data, where, imagine, if we have roads, right, as an example, from Tesla, as an example. Tesla has a lot of data. Why? Because they have zillions of cars going around in the roads, okay? So they collect the data. But they also do synthetic data with worlds that are generated in order to test specific conditions that are very rarely happening, okay? Imagine that if we have a manufacturing environment where we could test everything and collect data and more data, and we could bring the SMEs there to test and generate loads of data and test their sensors virtually, but also then, of course, physically. This is the idea of the TEFs and so on, but it takes a lot of time for this to develop. Maybe we'd need some orchestrated instrument in Europe to create this from one side or the other. Not to take
you
more
can
time.
pass to Sergio to
and
say
Sergio,
more,
because I gave the TEF lead, he's the TEF guy.
Let's benefit from the experience of made a very nice TEF or Digital Innovation Hub. All of us that have been in Milano have visited here, and it's a great facility. So maybe share some experience and some knowledge.
Yes, I would like also to address a bit the previous question, because you know I was coordinating AI Regio. I'm coordinating AI Regio 5.0, which are projects of I4MS, ICT Innovation for Manufacturing SMEs. So we really aimed to fill the gap, the digital divide between manufacturing SMEs and large manufacturing companies. And in this, we are experimenting with more than 60 SMEs between AI Regio and AI Regio, the new, especially AI at the edge solutions, and also human-machine interaction. And this is something that we need to do. So the digital divide with this very fast progress of the technologies, of the augmentation technologies in particular, the gap between SMEs and large enterprise risks to be much, much larger and urgent to fill. Say that, my personal opinion is that large manufacturing enterprise are really pushing, are really the impact creators for the new technologies. And so we really need, for instance, in Italy, we have a larger manufacturing industry in automotive, aerospace, textile, food, and so on. And we need really them to push the new technology, to experiment the new technologies. In the TEF, Testing Experimentation Facility, we accept both SMEs and the large enterprises. Of course, large enterprises are paying a bit more than SME, which usually are assessing the services free of charge. But what I wish to know is, I wish to say is one fundamental aspect, which is the user empowerment about augmentation technology. And so the ideal situation would be that every single worker is designing his or her workspace together with a company, together with a manufacturing SME. This is a dream. Of course, you cannot do it, but you can do it for special categories of workers. And we are running in Politecnico a project which is called Skill Liability, which is about dumb and deaf workers. And so how to introduce those workers into the manufacturing environment. And I believe that this exercise is, so large enterprises are mostly also dictated by law to hire disadvantaged people, mental or physical disadvantaged people. And so large enterprises have this, are sensible to this. Also because there is a regulatory compliance and they need to do it. SMEs, they could do it because they are very, very small scale. And so maybe they could do for 2 or 3 special workers, they really could do it to design together the workspaces they are going to work.
Okay, so I'm going to stress you a little bit. So starting from Sergio, and considering that I don't want to ask to run out of time, right? So 40 seconds each. And in 40 seconds, you say two things. First thing is what the shop floor of 2030 would look like in terms of augmentation. Is it going to be like this today or something different? I don't know, talking or more intelligent. And also, what is the role of EU project in a world that is running so fast in terms of manufacturing technology development? So 40 seconds each. You accept the challenge, right? Yeah. Yeah. Okay, shall I start? So I think the workspace of the future, 2030, it really depends on the sector. So you cannot make a general statement. You have seen this morning that in some sectors you could have totally unattended by people, by human workspaces, and the human is taking the role of supervisor. And in the control room, which maybe is miles away from the plant. In other sectors, this is not possible, and in other sectors, we really need this symbiosis. And I would call it symbiosis in the sense that the human and machine needs to find an agreement and so-called collaborative intelligence. What the projects can do, the European project, they can do really a lot. And we had a call about augmented technologies, which closed in September. And so we really hope that thanks to this project, with the collaboration of factories of the future, so I would also recommend the voice, not just the voice of the technologist, but also the voice of the manufacturing industry to be listened. Considered. Okay. Quite good in terms of time. Pedro, you
Yeah,
have to
very
be quicker.
fast. Very fast. So, in Europe, to be honest, I think in 5 years nothing will change, or very small things will change. We are really slow in adopting and changing things. So, I think we will see introduction of some of these elements and technology we discussed. I think the world will go much more into automation.
US, China, they will
yes,
automate.
They automate large-scale automation. We will take time.
In more sectors than
and more
maybe
sectors.
Sergio.
And what I think we will see is development of manufacturing of war technologies. This is something. I'm looking 5 years. So we enter in a Volkswagen plant, we will see tanks getting out of there, not Volkswagen cars. This is tragically, I think, what will happen.
To be politically correct, it's not war, it's defense.
Defense, yes. Well, yes, correct.
He wants to be more provocative. Nikos, 40 seconds maybe?
Okay. I will start with the projects. I think projects and the recent innovation projects that we are all here give the opportunity to experiment, test with minimized risk. And I think in Europe, that we are really conservative, only a few companies are willing to spend for R&D. Because spending in R&D is you burn money in hoping something to get out. Like 80 to 90% is failure, right? So this gives the chance to reduce a failure. I would like to play with the idea of Pedro and say it depends on how fast Europe will regulate. Because many times a new technology is hindered by regulation, which is not entirely bad. So I think in the future, we will, in 30, we will have more things automated, both software-wise and robot-wise, Industry 3, robotics, etc. But I will be bold enough to make a prediction for 2040 that then we will have a new generation of people that we cannot really understand right now, and many are younglings right now. So I think they are more, let's say, lenient and more accepted in these technologies, and they're sharing already many of their personal data. So many things of the regulation will be somehow be adopted for them. So I think in 2040 it will look more like an augmented workplace.
Allow
Professor,
me to yes,
you have the closing word.
Less than 40 seconds. So allow me to be a little bit more futuristic, maybe beyond 2030. So Sergio said the keyword seamless. I think in 10 years or 15 years from now, interactions and communication in a factory between humans and machine will be much more seamless than now. Even the AI agentic solutions you see dashboards. I believe that dashboards and tablets will disappear, and human-like communication will be established between humans and machines. It will start with the anthropoid robots, for sure, and it will finish to machines, to any kind of machine. Thank you.
Let's wish we are here in 2040 with good health and a larger scale core event. I hope you enjoyed the panel. Thank you very much.